This rule. Hello, Andre.
Hello.
Nice to see you. All right. So, rule 1, which was taught in grade 10. X to the A. X to the B is X to the A plus B. Yes, when you have two bases, you add exponents. Andre, get out some paper. It's nice to see you and your paper and a pencil. I'd like to see those as well. All right. So it's A plus B. So when you have two bases that are the same, you add exponents. Yes, you're looking like it's the first time you've seen it. Okay, so say I give you, sometimes we'll do it as a grade 10 one, x to the 3, x to the 5, I get x to the 8. Most people are good if the base is a variable. Sometimes you don't spot it as much if the base is a number. So if I give you this, 3 to the 2, and then 9 to the 4. Let's pretend. Right now you can do nothing if we do bases. Let's pretend that like you can't turn those into numbers. Don't go like typing them in. Okay? The only way I can put those together is if they actually have the same base, like x and x, correct? Because if I had x to the 2 times y to the 4, let's pretend, instead of 3s and 9s, that would be x2, y4. I couldn't put them together, correct? Can I make 9 somehow be 3? How? 3 to the 2. We don't want to use division, we want to use exponents, correct? So we don't want to go 3 times 3. We want to go 3 to the power of 2. So this would stay the same, 3 to the 2. And my 9 would be 3 to the 2 with a 4 beside it, which is going to be our next rule. What happens when we have this? We multiply them. So we would get 3 to the 2, 3 to the 8. So what would this actually be? 3 to the 10. So do you see these are the same base? I just rewrite the base. I don't put 9. Do you see? X and an X became X to the 8. Do you see that? So 3 and a 3 becomes 3 to the 10. You see how you can make more mistakes when that base is actually a number than when it is a variable? It's true. Yeah, you'll write a 9. You won't.
I don't see it.
Right. Thank you. Thank you. That's how you all are. No mistakes. Okay. Rule 2. If I have x to the a and a b outside, what is that? X to the ab. Now we're going to do a whole bunch of stuff, especially before your diploma. We're going to practice a whole bunch of stuff where I throw variables in spots, because you have to be able to do it without any with different numbers. And that was one of the things that the prof said that people struggle with in university, is being able to, if it's not a 2, 4, or 6, you can't do it. Like you're good with certain numbers, but then you get a different number, you can't do it, or you get a variable, you can't do it. So if we do it with variables, you can do it with any number then, right? If you would be able to do it with a variable, because variable includes every number. So say I give you x to the 2 and to a 3. What's that? What say you? X to the 6. 6, yes. We agree. So when one base, two exponents multiply, two bases, they have to be the same, then you add the exponents, correct? So what about rule 3? X to the a over x to the b. And over means divided by. What are we going to do? What? Subtract. I thought I heard factor. It was scaring me. I'm like, factoring is not always the answer. A minus b. I did say when you're stuck 97% of 98, I keep flipping between 97 and 98, it's GCF. This is not that time. Okay. So say I give you x to the 2 over x to the 8. What is that actually? X to the negative 6, because it would be 2 minus 8. We'll get to negative problems in a second. Okay, rule 4. What if I divide with an exponent outside? So say I have, it's kind of involving rule 2, but that's okay. Rule 4, say I give you x, y to the a. Pardon? I just can't hear anything. It's x to the a over y to the a. Most people are really good with that. What if I give you this? Let's put it to the a as well. Put it to variable, we can do it to variable, we can do it to anything. What do you think is the thing that people are going to forget to do? Yes, make the 3 to the power of a. Everyone does it to the x and everyone does it to the y, but they forget to do it to the coefficient. This is multiplied. So this goes to the 3, this goes to the x, this goes to the y. So we would get 3 to the a, x to the 2a over y to the a. So let's give it with actual numbers. 3x squared y cubed to the 3. Try that one. It would be 3 to the 3. Y to the 6 over y to the 9. And so we get 27 y6 over y9. And why did I put a y? That's an x. I'm not erasing it though. I believe in you. You can put the x. Y to the 9. 27x6 over y9. That's rule 4. Rule 5. So everyone's really good at this rule usually. X to the 0. What does that equal? 1. Everyone's good at going this direction. Everyone forgets you can go this direction as well. Why would you ever want to do that? Well, say I had this. 6 to the x plus 1, which is what we're going to do today, equals 1. And I want them to be base 6. What could I do with this? Change it to 6 to the 0. So 6 to the x plus 1 equals 6 to the 0. So whenever you have a 1 and you need to make a common base, remember that you can. It's just whatever that base is to the 0. Okay? That's a rule everyone forgets about. We're not going to solve it or do any of that right now. We're going to do that later, but I just wanted to remind you that you can change 1s to any base to the 0. That's usually where this rule comes up more so in 30 as opposed to in 10. Then we have rule 6. What if I have x to the negative 6? How can a negative exponent is actually fine, but what if they tell me I need to have positive exponents or they make them positive? Anyone remember the rule, Curtis? So you just move it to its denominator, putting it under 1, because this one doesn't have anything up here. So what you can do is, if you move something from the numerator to the denominator, it becomes positive. If you move a negative from the denominator to the numerator, it becomes positive. So when I move this to the denominator, I'm going to have x to the 6 in the denominator, and then I'm going to have a 1 in the numerator. Exactly. I believe in you. Big brain now. Okay, rule 7. Didn't hit really exponents as much, but I'm going to remind you of it because it's from grade 10, and we know about grade 10. It's a little scary sometimes. So, we talked about this before. If I give you the square root, this really isn't in exponents, but I'm going to put it in here anyways. If I give you the square root of x squared, that's a stupid one. Square root of x5. Square root of x squared is x, that's why it's stupid. How can I write this as an exponent? Not 3. You're close to what you're saying. How would you move it? What is the index? The number in the top, what's the index? It's a 2. So what do we do with it? You drop it underneath. So this actually is x to the 5 divided by 2. Yeah, you're very close. So all you do is you take that number in front and drop it underneath the exponent. This was a whole day's lesson in grade 10, just so you know. That was it. That's it. So, say it's like this. Say it's the cube root of x to the 2. What would this be the same as? X to the 2 over 3. And we use this a lot in calculus as well. Like they'll give you the, when you do derivatives, if you have radicals, you have to change them to exponents every single time. Every single time you have a radical, in order to find the derivative of it, you have to change it to an exponent instead of a radical. So say I give you just like the square root of x. What would that be? X to the 1/2, because this has an exponent of 1 if it doesn't have an exponent, and this has an index of 2 if it doesn't have an index. So it's just x to the 1/2. So any square root is to the 1/2, any cube root is to the 3rd. That's it. That literally was grade 10. You learned that for a whole day. And then you'd go reverse the other way. And now your life is not like this. Well, maybe you didn't learn. Whatever. It's there now. See? You're welcome. You learned it in 3 seconds. Same thing. Equally as good. All right. So we're going to do solving by common base. So the lesson today is solving by common base. So I'm going to give you one little thing here first. If I give you 3 to the x equals 3 to the smiley face, what can you tell me about that equation? X equals smiley face equals x. Right? So if we have the same base, our exponent's equal. We agree? You just stated that, correct? So what we're going to do is we haven't had to do this before. We've always been able to solve. Our x has always been either in a numerator, in a denominator, or a base, correct? That's where our variable has always been. But now our variable is going to actually be in the exponent, just like this, up here. So what you always want to check for first is if you can make common bases. Because if you can make common bases, then you can just set the exponents equal and boom, you can just do some normal math, some grade 10 linear math. That's it. Okay? So what we have to do is always, when our variable's in the exponent, we have to check first if we can do common base. Because if we can't do common base, we're going to have to use logs. Which we aren't doing right now, but that's okay. So, A. The title to this is Solve. And A is 2 to the x minus 1 equals 8. Now with common base, you always want to make them have a common base. The common base you want to make them have is the smallest common base, not the largest common base. You always want to make it be the smallest common base. So what common base can I make 2 and 8 be? 2. Now remember, common base is something to an exponent. Common base is not something divided by something or something times something, right? Like 8 is 2 times 4. That's lovely, not helpful, but lovely. It's true. It's a true statement, not helpful. Okay? We know that this is 2 to the x minus 1, and I can't make 2 be anything smaller, so I try and make 8 be 2. If I can't make 8 be 2, then I can't solve this by common base. Hint, hint, today's lesson is common base. So everything will be able to be solved by common base. So, yes, it's a good day. After today, it could change. It could be not just common base, but today, common base. So here we have 2 to the x minus 1 equals 2 to the what? 2 to the 3. Then what? Yeah, x minus 1 has to equal 3. That's the true statement that has to happen here, because if 2 equals 2, then this equals this. I can add my 1, and x has to equal 4. What's great about these? We can check them. We can verify. What's the steps for verification? Rewrite. Oops, don't go through your question, because that's really bad verification. Oops. And then we plug in. 2 to the 4 minus 1, 8. 2 to the 3, 8. And you might be like, left side equals right side. Remember, a toddler doesn't know those are the same. 8, 8. Not sure why I keep writing the 8 down this side. It's aggressive. Okay. And left side equals right side. Boom. We're golden. So first step, verification, rewrite it, fill in, get it, work, stuff, answer. Okay? Now this is also the cool thing. We know that the answer is 4. We agree? We can also check it with our calculator. So you're going to go y1, y2. Remember, when solving, whenever it says solve and you're missing one variable, you can y1, y2. It doesn't matter what math unit you're in. You can check every solving by y1, y2. Sometimes it's just really awful to write it in, but you can do it. So 2 to the x minus 1 equals 8. Type in y1, type in y2. Go. Then what do you want to do? Find out where the two equations intersect. Every single time it's the same thing. Second trace 5. Enter, enter, enter. All right. So, did you get 4 for your x? Yeah? Remember, your calculator can't calculate what it can't see. So say your answer is 12, right? Let's pretend your answer is 12. And your x max is at 10. And you go second trace 5, enter, 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 and you hit it viciously. And it's just like, no sign change. Or that's usually what it says. And you just get really mad at it. Remember that if you're trying to find x equals 12, but you're only letting it see x equals 10, it can't find it. So it's you, it's not them. You're the problem, not the calculator. Okay, so you have to adjust your x max. So whenever I do these, I solve them myself first and just use my calculator to check them, right? So I know what the answer is. So if the answer is 12, I go to my x max and I make sure it's a 12, right? Actually, I make sure it's a 13. You don't want it to be 12 because it fights that sometimes. You want it to be one more at least. Okay? All right. That one's a nice one. B. Now we're on green. I didn't realize that was happening, but you are. Okay. Yeah, I did. 9 to the x minus 1 equals 27 to the x. That's nothing.
You want to make it with a small space.
Always the smallest space. So what is the smallest space that I can make these both be? 3. Some people will say 9. Remember, 27 divided by 9 is lovely. 9 times 3 also great. Not helpful. Needs to be a base to an exponent. So 9 is 3 squared. X minus 1. And 27 is 3 to the 3 to the x. Now, this is what I always do. I always put my binomial exponent in brackets because the common error here is that people forget to distribute. Boom, boom. So that 2 has to go to both of them. And that's going to be, they're going to have the answer to the common error. Now, you should never pick it because you can check these with your calculator, right? If you're picking the common error because you didn't distribute, you didn't check to see that it didn't work by either algebra or by your calculator. And that's a problem. That's a bigger problem than you not distributing. Okay? So when you distribute, you get 3 to the 2x minus 2 equals 3 to the 3x. And then I can go 2x minus 2 equals 3x. Subtract 2x. Negative 2 equals x. So I know my x minimum on my calculator needs to be at least negative 3 if I'm going to check this in my calculator. So y1, y2, try this one out. Now remember, if you have an old calculator, if you have the older calculator's exponents, when it's a binomial, it has to be in brackets. Or it's doing this. It's going 9 to the power of x minus 1. If you don't put in brackets, it's going 9 to the power of x because it does BEDMAS rules, and then subtracting 1, which is not what you wanted to do. you want it to be 9 to the power of x minus 1. Remember, your calculator will always do brackets first because it does bedmass rules. So if you want something to happen, put it in brackets. If your exponent pops up, you don't need the brackets, but you can if you want to. y1, y2, try that one out. What about this one? 16 equals 1/2 to the x plus 4. What's my issue? Other than my volume on the computer's going. It's a fraction. So, I want to get rid of a fraction. What could I raise that 2 to the power of to get it to move up? -1. Because it's currently 2 to the 1, isn't it? If I want to make it move up here, I can make it be 2 to the -1. Negatives you can move to make positives. Positives you can move to make negatives. It doesn't really matter. So I can move this up so I can go 16 equals 2 to the -1 to the x plus 4. And I'll always do this as well. I'm going to raise this as 16 to the 1 so I know that it has an exponent as well. It's just exponent is just a 1. It's just nothing that important. Now I'm going to have to make 16 be base what? 2. And it's 2 to the what? 4. Because it's 4 times 1, which is just 2 to the 4. And then this one is going to be 2 to the -x minus 4. And so we're going to get 4 equals -x minus 4. I'm going to add 4. 8 equals -x. Divide by -1. X equals -8. So I know my window on my calculator is going to have to at least be at -9. Try it out. y1, y2. And this is the key thing. Everyone should try this because you will get it wrong. y1 is 16. And y2 is 1/2 to the power of x plus 4. This is what's going to happen. 1/2 to the power of x plus 4 looks something like this. Not really, but let's pretend. It moves to the left, so it's way over here. But nonetheless, next one. 16, though, y1 equals 16. Where is that? It's a horizontal line at what? At 16. It doesn't have any variables, does it? That's a horizontal line at 16. Your calculator's maxing out at 10. This is your window. And then up here, there's a horizontal line at y equals 16. And once again, you get mad and you say my calculator sucks and won't figure it out. It only has one graph. It literally can't find an intersection. Correct? So whatever your y1 here is, because it doesn't have a variable on it, do you see it doesn't have a variable? It's just y equals 16. Your y max is going to have to be bigger than 16 or it can't see that line. So you'll have to make your y max be 17 or 18. Something bigger than 16 or this horizontal line's floating up here and you can't find an intersection because it can't find it. Now what always works? Algebra. So could you not just take the -8 and plug it back into the original and make a match? Yes. Your calculator is just like an extra special thing you have. Okay, D. What if I give you this? We'll go like this. Easiest question done, the absolute worst any other question I've ever seen is done. How did I tell you can put bases together? You can only put bases together if they are actually what? The same. Like 3x, 3 to the 2, 3 to the 7, 3 to the 5, correct? So can I put this 5 and 2 together? They're being multiplied. Can I put them together? No, it's a 5 and a 2. Do you know how many people put 10 to the x? Common error 101. If you're that person, which is probably 97% of you, and would have done 10 to the x, leave yourself a little star, underline it, and say illegal. Oh, Mrs. Lepp, a bag of chips. Yeah, I wish I could give out chip tickets, like math tickets, but you owed me a bag of chips or something. It'd be like 900 pounds, but it would be tasty. I could buy you chips because you got something wrong. So that is the worst reverse math ticket I have ever heard of in my entire life. Like I would be positively reinforcing your crappy math. That's terrible. Those are some bad suggestions. I won't even take that one into.
Make so much money off of that TLC and not too much online. You have like 600 episodes credited.
Yeah, get a shot. My phone.
Yeah, I could be part of that. I would, just sold. Done. All right. Okay. So 5, 2 to the x equals 10. So instead of putting those two together, which is a bad decision, because you can't, because the only way you can put something with an exponent together is if it's the same base as something else, correct? Can't do. So what's the only thing I could do in this case? Divide the 5. Now, why can I divide the 5 over, but I can't multiply the 5 in? That's stupid. Why can't I do that? Right. So this one here is 2 to the x. This one actually has an exponent. 10 and 5 are just numbers. Can you do 10 divided by 5 in real life? Yes, you were taught since little you can do that. So that's not illegal. So we have 2 to the x equals 2. So the 10 and 5 you can divide because neither of them has an exponent. I don't know why I'm doing this, but 10 and 5 you can divide. Yes, you are welcome. I should just talk with my hand all class. Oh. What is the next step? It's like a puppet. Yes, so this is a 1 up here, so x equals 1. It's like a hand puppet.
No, that's what he does in The Shining.
He hand puppets? I'm doing The Shining?
Have you not seen it?
No, I just undid. I don't know. It sounds scary. Okay. E. Remember my little rule from earlier. It's going to come into effect. Now I'm going to tell you which rule it is. So we have 6 to the 2x minus 3 equals 1. Most people will completely spot that, or miss, not spot. They'll completely miss that this can be made common base. But it can. Because whenever something is a 1, you can make it a common base of anything by raising it to what?
0.
To the 0. So, this is 6 to the 2x minus 3, that stays. This is the only time when a small base becomes bigger. 6 to the 0. And now we have 2x minus 3 equals 0. Add 3. 2x equals 3. Divide by 2. X equals 3 halves. Okay. What if we do this? Here we go. So these are easier, we're going to do a bit harder, but they follow the same rules. I'm not joking. By making them harder, there's really not, I can't really do that crazy of things. So let's go F. 2 to the x minus 3 equals 4. 32 to the x. Got a math. All right. So we have 2, 4, and 32. We know that the 4 and the 32 can't join currently because they're both not what? The same base, and the 32 has an exponent. Okay, well, so the last lesson, or last 2 examples ago, we learned we can just divide the 4 over. Can I divide the 4 over? No, because the 2 has an exponent. Dag nabbit, all of our things we've learned have fallen apart. What could we do, though?
Because 4 and 32 have the same base.
Yes, what base could they be?
2.
2. Yes, good job. So we can make them all be base 2. 2 to the x minus 3. 4 is to the what? 1 currently, and so it's 2 to the 2? Yep. And 32 is 2 to the 5. And this is half the battle. Getting to this point makes me happy. This is half the battle. But still, things go wrong after this point. So common error 1 is people are like, 4 and 32, put them together. Solves all the world's problems. It's really bad. It doesn't solve problems. It actually makes you, it's just terrible. You get a 0 in a written response if you do that. It's really crappy. Okay? So we get past that common error and we get to this one. Then second common error happens. People will just go and rewrite it as x minus 3 equals 10x. Is that true? No. If we can get past this common error, everyone will get this question right, 100%. If we can get past this next step, people will get, unless like you make a stupid, silly like math error, but that just happens sometimes. So this is 2 to the x minus 3 equals 2 to the what? 5x plus 2 or 2 plus 5x, same thing. We agree. If you can get to this spot, life is good. So what can we do next now? Set the exponents equal, because we have 2 to the something equals 2 to the something. The only moment you are allowed to set your exponents equal is when you have a base to an exponent equals 1 base to an exponent. If you have 2 bases, you can't do it yet. People will try and do it here. You can't. You have 1 base exponent, then you can do it. We agree? Okay. So now we have x minus 3 equals 5x plus 2. Minus x, negative 3 equals 4x plus 2. Subtract 2. Negative 5 equals 4x. Divide by 4. X equals negative 5/4. And once again, you could check with your calculator. I don't remember what letter that was. F. G. You're going to try this one out. 1 over 9 to the x plus 1 equals 3. 81 to the 2x plus 1. Try that one. So, here we have 9 is 3 to the negative 2. Because 9 is to the negative 1, so it's 3 to the negative 2. Don't forget to distribute. 3 is 3 to the what? 3 to the 1. I know that if I give you just a 3 by itself, errors will fly, because you guys will treat it as a 0. Even though you know 3 to the 0 is not a 0. It's not, yeah. It's 1. Okay, I don't know where it's going. Now, 81 is 3 to the 4. 2x plus 1. So we're going to get 3 to the negative 2x minus 2 equals 3 to the 1 times 3 to the 8x plus 4. Remember to distribute. And then we get 3 to the negative 2x minus 2 equals 3 to the 8x plus 5. I don't know. And then we get negative 2x minus 2 equals 8x plus 5. Add 2x. Negative 2 equals 10x plus 5. Subtract 5. Negative 7 equals 10x. Divide by 10. X equals negative 7 over 10. All right? Big kahuna, ready? I'm going to make it up on my head. That's how big of a kahuna it is. Okay. H. Are we ready? It's not a bad idea. The answer may come out as a bad answer, but not a bad idea. So, I want to make something with a whole bunch of bases of 3. So if I wanted to like wing a question together with you guys and I wanted to make it hard, that's what I would do. Ready? 9 to the x plus 2 times 81 to the x minus 3 over 27 negative x plus 1 equals 3, bracket, which one have I not picked that's a 3?
Just 2 half, actually 4,000.
4,096 I think is a 3, isn't it?
That's 2 it.
Is it 2? I think that's a 2.
I don't know.
I need a common base of 3.
169.
You can always try the process.
243.
729.
What?
Nothing. Yeah, why not 69?
Why not maturity? I don't know.
I'm sorry, we haven't
I don't
got it. We're not.
I don't know.
Why is everyone laughing? That's just a number thing.
Yeah, it's like there's 69 and there's.
You guys are just like brutal.
69
It's just my favorite number is 9, and you're kidding around as a 6.
You're a dork.
Like if you draw.
All right.
If you draw a graph of how funny.
This is getting worse.
69.
Okay, I'm going to add more numbers to this.
Do it, please. Let's go.
So there is a faster way. It's a fun little ditty. It's called the store button. It can store your answer in for you. So it's another way you can check with your calculator. If it ever asks you to verify algebraically and you check it in your calculator, you can't take a picture of your calculator and put it on there. So that's a problem. So if it says verify algebraically, you cannot do this method. But it's a way you can check anything and every single one by verifying, letting your calculator do it for you. So what did you get as the answer? -6. Let's check it. We're going to do the work in a second, but I just want to show you how to use your calculator. So you're going to go to your calculator, and you're going to go to your main screen, and you're going to put in your answer. What was your answer? So you're going to go -6. Everyone following me? I literally just pressed -6. You there? You laugh at me. I'll go 2 more buttons and they'll be like, what'd you do? And you're going to press store. The stow with a button. Stow with a button. Stow with an arrow is what I meant. And you're going to store it as whatever variable you want. I'm going to use X because it's easier. You're going to have to alpha L the whole time to retype in the question. Just so you know. Okay. So we hit enter. And now my X currently is -6. I've stored it as that. If I store it as something else, it goes out. If I find an intersection, it leaves. If I calculate a max or min, that's the new X, right? Because I'm just storing it as X. So if you store it as a different variable, it will actually stay till whenever. But we're going to type in the actual main part here. So I'm going to go not to my y equals. I'm going to stay in my main screen, I can't speak. And I'm going to go 9 to the exponent, x plus 2. Like I'm literally typing it in with x's now, because I stored x as -6, right? And then times 81 to the power of x minus 3. Oh, crud.
You gotta do bracket.
I can press enter, but I'm rebel without a cost. So I'm going to go, if I press alpha link, will it make it a fraction? No. Cuckoo. That didn't work. I'm going to go second, insert bracket. So I have to retype it.
You added K. That's K9.
It's a K? Just alpha?
Just stored that as a bracket.
Sure. Okay. We're learning. I've never thought to do that. I don't even know if that would work. Okay, and then divided by bracket. This would have been way easier if I just used the fraction button, but you know, beggars can't be choosers. 27 to the power of -x plus 1. That's my answer. Pretty.
Much easier.
What do I still have to do? The other side. I don't know what just happened. There. No, I never put marks up or emails or anything, so that can't happen. Life lessons. So then we go 3, bracket, 729 to the power of 2x plus 1. 9 to the power of x plus 6. And they match. Thank you for whoever joined in with the taking of whatever you were doing. Okay. So, now let's do it actually mathematically, because if that's great, you can find it with your calculator, but if they ask you to do that correctly, you are in trouble. So, 9 is 3 squared. That's a lot. 3 squared, x plus 2. 81 is 3 to the 4, x minus 3. 27 is 3 to the 3, negative x plus 1. 3 to the 1. 729 is 3 to the, I don't remember what I picked anymore. 6. And then 9 is 3 squared. So I'm going to get 3 to the 2x plus 4 times 3 to the 4x minus 12 over 3 to the negative 3x plus 3 equals 3 to the 1, 3 to the 12x plus 6 over 3 to the 2x plus 12. The tops together. So I'm going to get 3 to the 6x minus 8 over 3 to the negative 3x plus 3 equals 3 to the 12x plus 7, if we add exponents, over 3 to the 2x plus 12. And now what do we have to do with the exponents? Subtract. We do not, this is what happens when it's a division. When it's a multiplication, you guys like put them together and everything's great. When it's division, you're like all the same. And then you drop them off and you go 6x minus 8 divided by 3. No. Bad. Bad news bears. So we have to subtract here. So we're going to get 3. 6x minus a minus 3 is 9x. And then negative 8 minus 3 is negative 11 equals 3 to the 12x minus 2x. And then 7 minus 12, negative 5. Now, when we have one base and one base, we can set the exponents equal, only at this point. So we get 9x minus 11 equals 10x minus 5 minus 9x. Something is going awry. Oh no, let's add over. Negative 6 equals x. How did I make that up and it worked out to such a nice answer? I was expecting like 1,743 over 10. Well, not really, but you know, something real awful. I'm thinking like 15 over 3, which is 5. That's not true. 15 over 2. Over 11 or something.
Did you check this? Because I did about the eighth of the steps you did, and I got the right answer.
Did you go like add, subtract?
I did, so I took the equation, and then all in one step, I took the 27, then I I took the minus x plus 1, I did plus x minus 1, and then in the same step, converted it to 3x minus 3. So I did I went from step 1, it's hard to answer.
Here to here.
I skipped that one too. And then I took the 3 up top,
Oh, and added them all.
and added them all.
That would work,
All in one step.
but I would show work. Because like I've said to you before, we don't know if you're the smart kid who can do that in one step. I know it, but I don't mark your diploma.
Okay.
I could be marking it and not know it's you. If I do spot like, hey, this is wout, if you wrote that on there, I'd have to hand it off to someone else just so you know I can be able to mark it. But if you go from 1 to the end, do you realize how that could just be calculator? Or a really smart kid?
I had a middle step.
Okay. Because they won't be able to decipher, right? They have to be able to tell. And if you don't know if you're a smart kid or something.
I have 4 steps. Yeah, including including the start and the
Okay,
answer.
so this one I can answer, but I don't have
The start and then it's like everything and then it's like the process and then like this
Okay,
I have like the start, like the basics, like the actual mission, and then I have like the bottom one that's not.
They have to be able to decipher.
And then I have like without it's like all put together and then the answer.
Or do you make it easy and show way less steps to make the process like that way you do 3 month question on the diploma and say you messed up in like step 2 and you want to wait like 6 months. So I don't want tons more steps, but one more would probably be nice.
Okay, so just like 3 to the power of 2x plus 4 plus.
And then I spin it.
Even just putting those together, 3 to the power of putting those together,
Okay.
then, yeah.
Equals.
Yeah. Yeah. Not like a ton more, just like maybe more. So we have 1 over 4 to the x plus 1 over 8 to the x minus 1, 16, 2x minus 3 equals 0. Who do you think you are? The square root of 2 to the x plus 1 over, yeah, it's going to be an exponent. It's not a stacked fraction.
Look at the left side. Is that on a stacked fraction on the left side?
No. You're going to make that be 4 to the negative 1, peeps. You're going to make it be 4 to the negative. You are going to. Don't use my words against me. Do not use my words against me. I like, isn't it? I think 2 to the something is 4,006. Okay. Okay, I'll give you 2 questions. That's 1. Number 2. Now, if you say to me, look, I don't know if I'm right. Yes, you do. You can check it algebraically. You can store it. You can go y1, y2. There's so many options, so little time. Okay? Check. Next one. What base do we want it to be? Not 1.
Something disgusting.
Base 17? 5.
700.
No.
5.
I want to get 700. What's the biggest number?
I think 645 is one.
The same with like 67. I like my 67. It's like numbers that can be divided by 18.
Not kidding. Straight facing y'all right now. That is 1,953,125.